Hello everyone, my name is Aaron Leatherwood, and this is my project from the Introduction to Remote Sensing class. My project was on the effects of sea level rise to, on St. Catharines and Sapelo Island from 1985 to 2025, specifically looking at the effects that it has on shoreline retreat, so the overall area of the islands, as well as the land cover change distribution that is affecting these islands. Now we're going to look at an introduction. So, a main thing about to know this is that sea level rise affects all the Georgia Barrier Islands through shoreline retreat in some way, shape, or manner. Some form that this is happening in. Shoreline retreat is an erosional process of a coastal body where from the permanent or passive submersion of coastal areas. So, in layman's terms, these coastal areas are now just going to be underwater for longer, causing these islands to change land cover types. So they'll go from beaches to marshes, marshes to beaches, things of that nature, as well as they could just overall lose area due to erosion. Um, in the case of the barrier islands, this is due to a lack of sediment supply and overall sea level rise. And as I said earlier, these barrier islands are all either actively shrinking or showing some effects of sea level rise. A deeper dive into the study area is going to be that of St. Catharines and Sapelo Island. St. Catharines is the northernmost island in the image to the right. It's about 32 kilometers south of Savannah, Georgia. It's about 14,600 acres to 22,600 acres wide. And a known fact is that it is slowly gaining area in the northeastern section of the map. Whereas Sapelo Island sits about 127 kilometers south of Atlanta and is about 16,500 acres wide. It is also slowly gaining area, but it is not to the extremity that St. Catharines is in the northeastern section of the map. So now we're going to look at the actual methods to get to the data that we want to analyze later on. So first thing that we're going to do is these things are broken up into four parts. They're broken up into data acquisition, pre-processing/correction, data analysis, and data visualization. Under the data acquisition section, all the images came from either a Landsat 5 TM level 1 or a Landsat 8 OLI level 1. Those images were then sent over to the NV 6.2 program where they underwent radiometric correction and were masked to fit the certain areas of interest specifically. For radiometric correction, it was done to the top of atmosphere reflectance with default scales and things of that nature, while the mask was a spatial subset showing the islands as well as the shape files specifically for those islands. So that way there was no reflectance made for anything outside of the wanted areas. For the data analysis section, so number 3, there are two main parts. So we had to find the areas of the island as well as do the actual change detection. The areas of the island, the first thing that was done was doing a supervised classification of the image. And based on that, so get all the training sites that we need and then run that through a supervised classification. After that, the area is calculated through the calculate statistics tool. The number of pixels is multiplied by 900 to get to meters, and then those meters are then converted to the other area units. The next thing that's done is an actual change detection. These change detection is done through the change detection tool within NV 6.2 on both islands from Sapelo and St. Catharines, on the 1985 image and the 2025 image to see what has changed the most in these 45 years. And then the last thing is the data visualization. So these maps are then, all these files are then moved to ArcPro to make final maps that actually look decently well and are able to be looked at. So now we're going to look at the results of sea level rise on shoreline retreat. So specifically, we're going to look at the area of St. Catharines Island and how that changed to determine if it has been losing or gaining area. So these are 3 of the 9 total tables that were made, looking from 1985 to 2025. This is the 1985, 2010, and 2025 maps. And overall, we see a few trends. We see that most land masses are growing. We see that one landmass is mainly growing, so the beaches go from 3.75% to a 3.4% to a 6.2%. So a drastic increase between 1985 to 2025. But we also see some landmasses change or grow as well. The dense vegetation land cover class goes from a 50.9% to a 49% to a 40%. So it is overall decreasing. It is turning to something else. you can assume. The As well as the marshland class. The marshland class is another one that is typically this is a good one to look at because St. Catherine's Island is primarily marshes, and it goes from 38% to 41% to a 45%. So it is steadily growing in comparison to what has happened the other. So we see this, but the actual area of the island is another thing that we want to look at. So these area of the islands are also steadily increasing, going from 11,424 acres, 12,198 acres, and so on and so forth, as showing the island slowly growing time. This is primarily due to the increase in area that we are getting in beaches. These beaches, primarily along the northeastern corner of St. Catherine's Island, is going to be the primary driver for this growth in land. Continuing looking at the area over time, we can actually see this change happen based on our Landsat classifications as well as the actual areas of it itself. If the areas are plotted over just time, so you take the 1985s and you go all the way to 2025, you can see that there is a slight increase. While the areas do fluctuate in certain areas, so 1985 to 1990, they gain. 2000 to 2005, there's a large gain. 2015 to 2020, there's a large change. There's an overall trend of it gaining landmass. These can also be seen in the actual images, the Landsat classification images. So on the bottom right, we have bottom left, we have the supervised classification of St. Catherine's Island in the 1985 image. And we can see that there is a small dot in the northeastern corner to where the sandbar actually starts to grow that we can see almost fully. That's what it looks like today in the 2025 image on the bottom right. So now we're going to look at the effects on Sapelo Island. Same as St. Catherine's, there are 3 of the 9 images here, so the 1985, 2010, and 2025 images, to kind of show what's happened to the island over time, rather than table per table. And there are some trends that can be observed here as well, almost that are very eerie to what is happening to St. Catherine's Island, just not to the same extreme. The beach land cover class is growing in area, going from a 2.7% to a 3.8% to ending at a 4.2% today of all total land. The sparse vegetation class is slightly growing, going from a 12% to a 3.2%. The marshland land cover class is growing also, going from a 3.1% to a 36% to a 38.17% of all total land, of all the total land encompassing the island. We can also see that the areas are increasing of the island, similar to that of St. Catherine's. This going from a 22,074 acres to 23,398 acres, and so forth and so forth. And this is likely due to something similar that's happening to St. Catherine's, but the accretion of these small islands, these small sandbars off the coast of Sapelo Island. Actually plotting the Sapelo area over time, similar to that, is what we did to St. Catherine's Island. So going from the 1985 area all the way to the 2025 area, we can actually see that the island is still overall gaining. While there has been some massive changes from 1985 to 1990, 1990 to 1995, 2010 to 2015, 2015 to 2020, these are massive changes in the island, and the area of the island is still an overall positive trend of gaining land. And these can actually be seen in the bottom left and bottom right images when looking at where these areas could be coming from. In the bottom left image, we see that it is the supervised classification of Sapelo Island from 1985, and we can see that these small islands in the southeastern corner, southwestern corner, northeastern corner, and northwestern corner don't really exist in this image. Whereas if we go to the 2025 image, the 2025 supervised classification in the bottom right corner, we can see that these islands slowly start to exist more and grow. The northeastern island and the southwestern island actually start slowly growing and filling out. So now we're going to look at the land cover distribution changes that is occurring on the island. So how these islands are acting in response to the rising sea level. So looking at the St. Catherine's Island, these are based off Landsat images acquired in 1985 and 2025. We can see that most of all beaches turn to open water. So 6% of these beaches turn to open water. Sparse vegetation, 11% of that turns to beaches. Dense vegetation, we have 33% of that turning to sparse vegetation. And marshlands, we have 26% of that turning to open water. So this is all in response to how the sea level is rising, causing these causing these land covers to transition to different types. You can see that in the bottom image, in the image directly underneath that. So the land cover map of St. Catherine's Island, uh, based off the beach land cover class. We can actually see that where along these coastal areas, based off the coastal areas, we can actually see that primarily a lot of it is becoming the beach land. What was the beach land cover class in 1985, and it was actually becoming a water land cover class or something else. Now we're looking at the other image, so the change detection from Sapelo based off the same time period. We can see very similar trends in comparison when comparing that to St. Catherine. So beaches, we have a lot of the beaches turning into open water or marshes, so 3.6% or 2.7%. We have, looking at the sparse vegetation, we have 20% of that turning to beaches, which is higher than that in St. Catherine's, but it's a noticeable change. We have dense vegetation with 38% of that turning to sparse vegetation. And then we have marshes, where 27% of that turns to open water. As just like what's happening on St. Catherine's Island, these islands, this is the effect that this island has on sea level rise. So as sea levels are rising, these land covers are transitioning either to open water, to marshes, etc., etc. And we can see that on the bottom image, especially when looking at Sapelo, we can see that it is what used to be the beach land cover class in the 1985 image is actually transitioning to the open water land class, or the marshland class. So the last thing I want to talk about is like the discussion and the conclusion. So what are some of the key takeaways to know from what I have done? And it is that the islands are gaining in terms of area. So in the case of St. Catherine's and Sapelo, it's primarily gained through the accretion of sandbars off the coast of the island. These sandbars are likely due to the erosional processes off one side of the island, then depositing that sediment somewhere else for the time being. The land cover chain is showing the transition of different land cover classes in response to sea level rise, which makes sense. So we have marshes and beaches typically going to open water. We have sparse vegetation going to marshes and beaches. This is present on both the islands, St. Catherine's and Sapelo. Little thing to know is that remote sensing can be used to get a better understanding of what is actually occurring, not just on these islands, but everywhere coastal in response to sea level rise. So actually seeing the changes in the area of this location, actually seeing what is occurring land cover wise in respect. Another thing to know is that a more year-to-year change detection analysis can be made to actually can be used in tandem with ground data to determine rates at which these changes are occurring